let's talk about one of the most powerful ideas in all of software, object-oriented programming, or OOP. But here's the secret. It isn't just about code. It's a whole different way of looking at the world. And to get it, we're going to start with a kind of weird question for you.
So, I want you to do something for me. Just look in a mirror. Or, hey, look at the person next to you and ask yourself, am I an object? It sounds a little strange, I know, but trust me, in the world of programming, the answer is, well, it's gonna surprise you. And the answer is a big, resounding yes. In object-oriented programming, we are all objects. An object is really just anything that exists in the real world. You, your car, your pet, even your bank account. In the eyes of OOP, they're all objects. Okay, so what makes something an object in programming terms? It's actually pretty simple. It's any entity that has two key things: data, which we call attributes, and code, which we call behaviors. Think about yourself for a second. You have attributes, right? Like your height and your eye color. And you have behaviors, things you can do, like walking, talking, or teaching. That combination of what you are and what you can do, that's what makes you an object. Now, to really appreciate why this was such a game changer, you kind of have to see what things were like before. So let's compare the old way of programming with this new OOP approach. So the old way, procedural programming, was all about the actions, the functions. OOP completely flips the script. It focuses on the data and the objects themselves. And the big deal here is how that changes security and flexibility. By building from the ground up and hiding data, OOP gives us software that's way more secure and a whole lot easier to manage and grow over time. You know, that bottom-up approach is a lot like building a house. You wouldn't start with the roof and just hope it all works out, right? No way. You start with the most basic thing, the individual bricks. Those bricks, they're your objects. You define them first, and then you start putting them together to build walls, rooms, and eventually the entire house, your complete software system. Okay, so if our software is built from these object bricks, where do the bricks themselves even come from? Well, the answer lies in two of the most fundamental ideas in all of OOP: classes and objects. Everything starts with a class. A class is the master blueprint, the master plan. And this is super important. It is not the real thing. It's not the house, it's the architectural drawings for the house. It defines all the properties and capabilities that any object created from it is going to have. So for a student class, the blueprint might say every single student must have a name and a roll number. And once you have that blueprint, then you can create your objects. An object is the real thing, the actual house built from the plans. We call it an instance of the class. And this is where it gets so powerful. You can use that one student blueprint to create hundreds, even thousands of different student objects, each with their own unique name and roll number, but all of them follow the rules of that original blueprint. All right, so we have our blueprints and our objects. Now we get to the really fun part. OOP is built on 4 core principles. And honestly, the best way to think about them is as superpowers. Seriously, they're what make this approach so incredibly effective. They're called encapsulation, abstraction, inheritance, and polymorphism. I know, they sound super technical, maybe a little intimidating, but don't worry. I promise you, the ideas behind these big words are concepts you already understand from the real world. So let's break them down. First up, encapsulation. This is all about security. It means bundling your data, like your bank balance, and the code that operates on it, like withdrawal, into one secure little unit, or capsule. You can't just reach in and change your balance to $1 million, no. You have to use the official withdrawal function, which has its own set of rules. It protects your data from being messed with. Next is abstraction. This is the superpower of hiding all the messy details. I mean, when you drive a car, you only need to know about the steering wheel, the gas, and the brake. You don't need a PhD in mechanical engineering to get to the grocery store, right? That's abstraction. It shows you only the essential features you need and hides all the complex junk under the hood, making things so much easier to use. Our third superpower is inheritance, and it's all about being efficient and reusing your work. Let's say you have a parent class called Animal, and its blueprint says all animals can eat and sleep. Well, now you can create child classes, like Dog and Cat, that automatically inherit those abilities. You don't have to rewrite the code. They get it for free. Then you just add their own unique things, like Bark for the dog or Meow for the cat.
And finally, we get to polymorphism. It's a fancy word that literally just means many forms. And the core idea is simple. One name, but lots of different behaviors. It lets a single action mean different things depending on the situation.
In fact, you are the perfect example of this. Think about it. There's only one you, but you behave differently depending on the context. How you act as a student in class is different from how you act as a child with your parents or as a friend. You're the same person with one name, but you have many forms of behavior. That's polymorphism. Okay, so we've covered the what and the how. We've seen the blueprints, the objects, the superpowers, but let's bring it all home and answer the most important question. Why does any of this actually matter? Why has this approach dominated software for decades?
It really all comes down to the practical benefits of those superpowers. Inheritance lets us reuse code so we build things faster. Encapsulation gives us that rock-solid data security. Abstraction makes massive software projects manageable. And the whole thing, by modeling the real world, just makes code that's easier for us humans to understand, to maintain, and to build upon. So I'll leave you with this final thought. Now that you get the core idea of classes as blueprints and objects as the real-world things you create from them, where else do you see this pattern? Think about a cookie cutter and the cookies it makes, or a recipe and the meal you cook. This object-oriented way of thinking truly is everywhere once you start looking for it. And that is the power of a good blueprint.